So sorry, everybody. Okay, so allow me to share the screen with you. This is all the stuff I made on the weekend. I'm going to put it up on your chapter 2. At the end of chapter 2, I'm going to put all this pictures, and I'll also put an assignment for you this week. Sometime this week, you guys. I'm working my butt off for you. But let's see. I just love teaching you guys. I'm sorry, you ended up with a teaching teacher. All right, so now this is the celestial sphere. It's the sky, and it's a sphere. Now, why is it a sphere? Because when we look from the Earth, and the Earth is a lot smaller, it's not even the size of a microbe as compared to the size of this sky. And when we look at the sky, we see this gigantic sphere, a humongous sphere, but our eyes are limited. So we can only see so far away, and we can't really tell distances. And so when you look at the sun, 93 million miles away, when you look at the moon, 200,000 miles away, we can't tell the difference. Everything appears to be inside of this giant sphere. So the sky appears to be a sphere because we see equally far away, but it appears to be equally far away in all directions. That's why. All right, and the Earth is rotating once every 23 hours and 56 minutes. And that explains everything that we see in the sky, with the exception of the tilt of the Earth, which we'll discuss today. All right, so here is the Earth itself. The Earth has coordinates. These coordinates are useful if you're delivering things to people's houses or if you're flying around the country. These coordinates help you to get from point A to point B. On the surface of the sphere, however, when you go on the surface of the sphere, the closest distance between 2 points is not a straight line because you're not going through the Earth. You can't tunnel through the Earth. So it is actually what is called a big curve here, big giant curve. So that's how you fly. Now, the Earth has poles. That's the rotational axis of the Earth. We have one at the North Pole. We have one at the South Pole. And in between, we have the equator of the Earth. So we say the equator is 0 degrees latitude. And there's no north or south yet. As you go towards the North Pole, latitude increases all the way to 90 degrees. It's a 90-degree angle. If you look at it like this, it's a 90-degree angle. And goes all the way to 90 degrees south. Again, this is 90 degrees from the equator to the South Pole. And so we go latitudes increase like this. This is something like, I don't know, 10 degrees, 20 degrees, 23.5 degrees is called the Tropic of Cancer. Why did they call it the Tropic of Cancer? Well, here, 23.5 degrees north, the sun is actually at the zenith between Tropic of Cancer and Tropic of Capricorn. So if you live between these two lines, then the sun appears at your zenith. We live at 32.5 degrees north. For us, the sun at the highest point, first day of summer, is only 81 degrees. That's it. It never gets to be at the zenith for us. But here, the tropics, it gets to be at the zenith. That's why they call it tropics. All right. Now, let's take a look again. Here's another view of the same. There's 90 degrees. That's where Santa lives. This is the equator of the Earth. And we also have something called the prime meridian. This prime meridian is a line that goes between North Celestial Pole, Greenwich, England, and South Celestial Pole. This prime meridian is 0 degrees longitude. It's neither east or west at Greenwich, England. Now, there's a line there. If you go east of that line, you'd be in the Eastern Hemisphere. If you're west of that line, you'd be in the Western Hemisphere. And it's a little different than latitude. It goes from 0 to 180 degrees. So it goes 10 degrees east, 20 degrees east, 30 degrees east, all the way to 180 degrees east on the back of the Earth. And then we go to the Western Hemisphere, same thing, 10 degrees west, 20 degrees west, and so on. Our latitude and longitude in San Diego are 32.5 degrees north, 117 degrees west of Greenwich, England. All right, now horizon is a line between wherever you live and the sky. So it's a line, right? And it also appears to be a circle. On top of your head, there's a zenith. Now, why is the horizon a circle? Because we only see 3 miles in all the directions that we look. Regardless of which direction we look, we can only see 3 miles. And so it also appears to be a circle Because only in a circle, if you happen to be in the middle of the circle, the perimeter of the circle is equally far away. And so it appears to be a circle. There is no horizon. There is no sphere of the sky. But it sure appears to us as human beings with our unaided eye, that means without binoculars or telescope, to be a sphere in a circle. All right, so now if you go to the beach and you look at the horizon, it looks like a line. Well, if you keep turning your head, eventually this line comes back, and behind your head, it becomes a circle. So if you keep going around, eventually it turns into a circle. Now, here's your horizon. Here is the zenith on your horizon. So top of your head is the horizon. This guy is pointing at the zenith. And this is the southern sky. Everything south of this is the southern sky. We'll get to that in a second. The point I'm trying to make here is that there's a star in the sky. How many degrees above the horizon this star is called altitude. So this blue angle here is the altitude of the star. How many degrees above your horizon? And then how many degrees east of north it is. So you start from the north and you go this way, east. This is your azimuth. So this would be 90-degree azimuth. This would be 180-degree azimuth, 270-degree azimuth, back to 359 degrees azimuth, 0. So 0 means you're looking directly north at your horizon. So azimuth, this angle here, altitude. That's the altitude and azimuth of the star. There is another coordinate system for the stars because the altitude and azimuth continuously change for the stars in the sky. So the sky also has its own coordinates, which we'll talk about next time. All right, so this is how you measure it. If you're looking at the horizon, that'd be 0 degrees. This is about 30 degrees above the horizon, 60 degrees above the horizon, 90 degrees will be your zenith. All right, so now here's the Earth in the middle of the celestial sphere. Celestial sphere is infinite, and the Earth has to have some kind of a size. So when you look at it, you can see it. Otherwise, you won't be able to see it. So we can see it. And now, if we get the equator of the Earth and expand it and expand it and expand it, eventually the equator of the Earth is going to hit the sky, and that produces what we call the celestial equator. So the celestial equator divides the sky into northern sky and southern sky. And we also have north celestial pole, which is the extension of the axis of the Earth. So this is a north pole of the Earth. It hits the north celestial pole. Then the south axis of the Earth hits the south celestial pole. So there's north and south celestial poles. And the Earth is rotating. So as the Earth rotates, we don't see that. But we do see the sky rotating around the Earth. So mistakenly, the ancients used to think that there is a sphere that rotates around the Earth. It's totally understandable if you think of Earth as being a stationary sphere, right? But they actually knew that the Earth was a sphere even back then. Because some people still are arguing about the Earth being a sphere or a flat. That's amazing. It's 21st century. I don't understand that at all. All right, so now here's Santa living on the Earth. So the equator of the Earth is over here. There's a North Pole. And here we say North Celestial Pole is 90 degrees above Santa's head. And so at Santa's zenith, he sees North Celestial Pole. And here's the celestial equator. Celestial equator goes around Santa's horizon. So Santa's horizon is the celestial equator. That's what Santa sees when he looks around his horizon. He sees celestial equator. All right, now there's one more line I'm going to introduce to you today. When things rise because the Earth is rotating from west towards the east, things appear to rise in the east and they set in the west. However, as things rise in the east, they rise and rise and rise and rise, and they get to a line called meridian. And then after that, they set. So something rises here, and then it reaches a meridian, and then it sets. So the meridian is a line This is a local meridian, and this local meridian is north, wherever you live, your horizon, north, all the way to your zenith, down to the southern cardinal direction in your vicinity, wherever you live. So this line is called meridian. Everything rises to the meridian, and then they start setting. So in the eastern half of the sky, things are rising. In the western half of the sky, everything is setting. Here's another diagram. I'm so sorry. I guess I got carried away. I was just worried about you guys' first quiz. So I made all these diagrams. Now, these are the horizons wherever you live. So this is about 80 degrees north. If you live 80 degrees north, celestial sphere above your horizon appears like that. You see part of the southern sky. You also see lots of the northern sky, all of the northern sky. So now this is the North Pole of the Earth. And so North Celestial Pole, where you live here, this is your horizon, remember, is over here. Your zenith is over here. That's top of your head. So here, North Celestial Pole will be 80 degrees above your horizon, the same as your latitude. Here, this is about 30 degrees north. So if you live here, your horizon is compared to the Earth, looks like this. And North Celestial Pole, again, parallel to the North Pole of the Earth, is over here. It's about 30 degrees above your horizon here. And then your zenith is over here. And then celestial equator is over here, again, parallel to the equator of the Earth. So your local sky looks kind of like this. All right. I made so many diagrams for you guys. This is horizon of the Earth's North Pole. So here's Santa. Now, one thing I like you to notice, this is the celestial equator. It's also Santa's horizon. Again, north sky is above, northern sky is above the celestial equator. So Santa's horizon is the celestial equator. Southern sky is below it. Santa doesn't see any of the southern sky at all. And he sees the stars going like this around North Celestial Pole. Again, zenith is at North Celestial Pole here, right? So zenith is pointing to North Celestial Pole. Santa sees North Celestial Pole at his zenith. But if you notice, everything in the sky is going around and around every 23 hours and 56 minutes, with the exception of the sun and the moon. Now, look at these stars. They all go parallel with the equator of the sky. So all the stars go parallel. Therefore, Santa has all the stars just go parallel. They never set for him. They keep going around and around. So if there's a star here at the equator, it just keeps going around and around for Santa. Right?
Professor?
Yes.
And you know how you brought up the meridian, right? The line. So that only goes from the west to the east, or is it like left and right only? Or
okay, meridian, this is the local meridian where you live right now, right? So you grab a line from north, wherever you live, the north direction. It's called the cardinal direction. You draw a line from north to your zenith, highest point in the sky, to the south. So this line divides the sky into two halves for you. The eastern half of the sky and the western half of the sky. Does that answer your question?
So basically it only goes from north to south and it separates both east and west.
Correct. It also goes through your zenith, the highest point in the sky for you. So everything has to cross that line to rise and set. All right, well here, everything, I'm sorry, yes?
I have a question as well.
Yes, please.
When back on the last diagram, when you say like when someone was at like 10 degrees north, or when their horizon was 10 degrees above the celestial North Pole, say on the diagram on the left, since they're at like an angle, they're not really looking at the celestial North Pole, because wouldn't they have to be on the direct North Pole of the Earth to see that?
No, you can see it where you live. North Celestial Pole, where you live right now, is 32.5 degrees above your northern horizon. So here's 80 degrees north. It's 80 degrees above his horizon right here.
Okay. I guess I'm confused because I've like if you go horizontally to the left or to the right, I guess it doesn't change whether the celestial North Pole, and I guess I'm kind of confused on how.
Well, that's why I'm showing you all this so I can cover everything. So this is just one way of looking at it. I have quite a few other ways to look at it. So just hang on for a second. All right. So we're just doing Santa right now. So Santa sees stars keep going round and around his horizon, right? You just keep going. Nothing ever sets for Santa. Now, we come back to this picture again. This is somebody living at the equator of the Earth. So take a look at the equator of the Earth. Again, the stars are going around and around North Celestial Pole and South Celestial Pole. South Celestial Pole is going to be here somewhere. So the stars are also going this way. Now, she lives at 0 degrees north. So that's how high above her horizon North Celestial Pole is going to be. So when she looks in the northern direction, she sees North Celestial Pole at the horizon right here, at her horizon. And so the stars keep going above the horizon, below the horizon, above the horizon, below the horizon. Opposite of Santa. For Santa, everything was just going like this.
So she would see the celestial North Pole at 90 degrees north for her.
She sees North Celestial Pole 0 degrees above the horizon. It's at her horizon.
I see. Understood.
It's at her horizon, right? 0 degrees. So her latitude is 0. She sees North Celestial Pole at her horizon.
And she sees South Celestial Pole also at 0, right?
That's right. She sees that too. So she has to go on top of a mountain if she wants to physically see North and South Celestial Poles above her horizon. She needs to go, on like 1,000-foot hill. Then she can see both. So she's the only person that can see North Celestial Pole and South Celestial Pole, and also the only person to see the entire sky. She can see the northern sky and the southern sky, both, because the Earth is rotating. So she'll be over here, she can see the rest of the sky as the Earth rotates.
So is she at Greenwich?
She is at the equator.
Oh, okay.
Greenwich is like 55 degrees north in England.
And Greenwich is where the prime meridian goes through.
That's right. That goes from North Pole of the Earth through Greenwich down to South Pole of the Earth. Okay, there is more, but then there is more. Okay, so this is San Diego. All right, so I'm in San Diego now, right? My zenith is over here. Where's my zenith? And I'm going to ask you guys the angle from North Celestial Pole to zenith in just a second. But so when I live at the zenith, when I live at the San Diego, this is my horizon. And North Celestial Pole, again, this is North Celestial Pole is 32.5 degrees above my horizon. The same as my latitude. So here's San Diego horizon. I said the altitude of North Celestial Pole or South Celestial Pole on Earth are the same as the latitude of the observer. So my latitude is 32.5 degrees. North Celestial Pole is 32.5 degrees above my horizon. If I lived at 50 degrees north, then North Celestial Pole will be over here. Now, question. Can anybody guess how many degrees above horizon zenith is?
7.5.
Okay, listen to my question one more time. Listen to my question one more time, please, okay? When I look at my zenith, you can look at your zenith. How many degrees above your horizon will you find zenith where you live?
Would it be 32?
90.
How many degrees above your horizon is the zenith?
90 degrees.
90.
Who said 90 degrees? Who said 90? Give me your last name, please.
Yates.
Ulrich.
Ulrich?
Mm-hmm.
Okay, how do you spell Ulrich? Oh, you. I'm sorry. This is Linda. Okay, Ulrich. Yeah, okay. Thank you, Linda. That's right. That's got a point. That's right. The zenith is always 90 degrees above your horizon. Always. Doesn't matter where North Celestial Pole is, South Celestial Pole is. zenith is always on top of your head, is always 90 degrees above your horizon. It's north celestial pole and south celestial pole that keeps changing as you change your latitude. Zenith has nothing to do with your latitude or longitude. It strictly has to do with wherever you are, where you live. It's always 90 degrees above your horizon. It's on top of your head, right? And yet there is more. Sheesh, there's more. All right. I'm sorry, I made all this little stupid drawings for you, but hey, let's see what we got here. So here we have, again, San Diego, except I filled up my horizon so you can see where I live. My bicycle is parked here. There is my horizon, is a line right there. There's my horizon. Now, North Celestial Pole is over here. This is always going to be 32.5 degrees above my horizon in San Diego. But then there's a question, because this is a northern sky. Everything above the equator, and this purple thing or blue thing is the celestial equator. I also fill that up. So this is also Santa's horizon too. Remember, the celestial equator goes around Santa's horizon too. So if I was Santa, this would be my horizon. But I'm Sina living in San Diego, so here's my horizon. No, remember, this is a celestial equator. Everything above the celestial equator towards the north is northern sky. This is all northern sky. Everything below the celestial equator is called southern sky. Now, living in San Diego, I can see the entire northern sky. But now, see, this stuff is below my horizon still, but I can see it when the horizon rotates, because things rise and set, right? So I can see the entire northern sky. But I see this much of the southern sky too. This much is below my southern horizon. So question is, how many degrees of southern sky do I see? The answer is, that's right, 90 degrees minus your latitude is equal to how many degrees of southern sky is visible from San Diego. So 90 minus 32.5 gives you 57.5 degrees of southern sky. Now, I'm going to put all this in a video and send it to you soon. If I asked you, while showing you this, if I asked you, if you live in England, 50 degrees north, how many degrees of southern sky is visible from England, 55 degrees north? You would say how many degrees?
35.
40.
35 degrees.
55 would be 35 degrees. Who said 35 degrees?
Cindy.
I'm sorry, who?
Cindy.
A bunch of people.
Cindy. You got to give me your
Cindy.
last name. I only heard two people. Cindy, what is your last name?
Costa.
I'm sorry?
Costa, among other people, of course.
Costa, among other people. Okay. So your last name is Costa, among other people. And who else do I have?
Tran, Jennifer.
Jennifer said that? Okay. All right. Thank you, guys. So how did you get 35? You said if England was 55 degrees north, you say 90 minus 55. That gives you 35 degrees of southern sky. Right. All right. So two things. How many degrees of southern sky is visible from a given location? Or you can say how many degrees of northern sky is visible. So if you lived at 20 degrees south, how many degrees of northern sky can you see?
70 degrees.
70
All right,
degrees.
so there was only one person that I heard go first, and it was a man.
Yates.
Carson Miller.
Carson Miller.
I said 70 degrees. I don't know if that's the right answer.
That's correct, yes. So
But
how
I
did,
said it first.
how did you get that? Carson, how did you get 70 degrees?
Oh, well, you subtract for like the opposite equator, the one that when you are 20 degrees north or 20 degrees south, you subtract your latitude from.
It's always, yeah, it doesn't matter. Yeah, it doesn't
90.
matter if you're south latitude, north latitude, you just subtract 90 from that.
Yeah.
So 90
Sure.
minus 20 gives you
70. Yeah.
70 degrees. Very good. Excellent. Now, another question that we'll ask later during, this video that I'm making for you is like, how many degrees above your horizon is, say, southern Mexico, 10 degrees north?
80. 80
How many
degrees.
degrees above your horizon is North Celestial Pole? Is
80 degrees.
at 10
degrees.
north.
10.
10.
10 degrees. That's right.
10.
Now, you don't get a lollipop right now. So if you live at 20 degrees north, it'd be 20 degrees above your horizon. If you live at 50 degrees north, it'd be 50 degrees above your horizon, right? It's
What
the
would be?
same as your latitude.
Sorry, what would be at the same as your latitude?
The altitude of north or south celestial poles,
Thank you.
wherever you live. You're welcome. And then you say how many degrees of northern sky or southern sky you can see. Then you have to subtract 90 for that latitude from 90. Then that's what you get, how many degrees of the other part of the hemisphere you can see. All right, so 2 things. Now, there might be another question like this. Help Captain Sparrow. Captain Sparrow is lost at sea. He looks up and he sees South Celestial Pole, 30 degrees above his horizon. And you say, what is Captain Sparrow's latitude? And then you
30
say,
degrees. 30 degrees.
then
Right?
you say, not yet.
No.
Negative 30 degrees.
60 degrees?
60?
No. There's 30 degrees.
Repeat
All
the
right.
question.
You have to finish it.
90 degrees.
No, it's 30 degrees.
30 degrees
South. That's right. You have to say south. You can't just say 30 degrees to latitude. Specifically because this is southern sky, right? So we have
Mind
to say,
repeating the question, Professor? I'm sorry.
sure.
I want to make sure I was focusing.
Captain Sparrow is lost and he sees South Celestial Pole 30 degrees above his horizon.
Aha, okay.
What is his latitude? You have to say 30 degrees south. All right. You have to finish it. You can't just say 30 degrees. That's not a latitude. Latitude is either north or south. You have to say that 30 or north or south. All right. All right. Any other questions, you guys, while I'm here?
No.
So I'll put all these pictures for you guys too, so you can use them all. Because I wrote all this stuff for you, so you might as well use them. No other questions? Okay. All right.
Are you you said you're sending us a video of all of these, or will
I'm
they?
going to make a video of these as an assignment too. So it'll be like 6 questions I'll ask directly during it. And most likely these questions in some form are also going to be on your first quiz. And probably on your exam too. You know, I'm going to get you guys ready. I want you guys to do well. I don't want you guys to do badly. Some teachers are like that, though. I remember some of the teachers in school, they just wanted me to get an F or C or something. So we have to kill ourselves to get a B. Yeah, there are those teachers. You know, I don't know what their problem is, but they got a problem. All right. Okay. So now, today we're going to do the revolution of the Earth, which means the Earth going around the sun. Can you guys see this behind me? So the Earth goes around the sun this way. Everything is backwards here on my video. So as it goes around the sun like this is counterclockwise as seen from the North Pole. Now I'm going to get on the board in just a second and show you guys that this revolution of the Earth also causes the seasons. So should I show it to you first, then show you some GIFs, or vice versa? I think I'll show you how it's done first on the board, then I'll show you guys little videos, then do a couple of more things. I want to do you guys as zodiacal charts too, real quick. At least your sun signs. Right. So if you're into astrology, I'll do a little astrology for you today too. All right. Now, why is this camera flopping? I have no idea. It's flopping a little bit. All right. So here's the Earth going around the sun. Here's the sun. Here's the Earth. And what I haven't told you is, remember I had the Earth in the middle of celestial sphere? And it's straight. It's a good boy, right? Standing straight. And so now the Earth is standing straight. But when it goes around the sun, it is tilted. So if I show it to you in the middle of celestial sphere, the Earth is a good boy standing up straight. But when it's going around the sun, it goes sideways like this, right? That's all. So now this is the tilt of the Earth's axis. And the tilt is as compared to this Earth's plane. This is called the Earth's plane. Can you guys imagine a plane here? like a sheet of paper, this giant sheet of paper. And this giant sheet of paper is the Earth's orbit. So every time the Earth goes around the sun, it goes on a sheet of paper, right? So kind of like this, you guys. Sheesh. I don't know. Like this, right? Every time it goes on this sheet of paper. This sheet of paper is the plane of the Earth's orbit. That's what they call it. So this is a plane of the Earth's orbit. All right, so there's the Earth's plane. Now, the reason I'm giving the Earth's plane is because of the tilt of the Earth. Everybody says the Earth's orbit is tilted 23.5 degrees. But what is that 23.5 degrees as compared to what? Right? Well, it turns out, as this is the tricky part, you guys. Let me maybe put it down and give you a diagram instead. So if this is the Earth's plane, what happens if I show you guys the Earth's plane from the stage? All you see is a line. You see that? There's a line.
Mm-hmm.
Here's the Earth's plane, and then if I tilt it, you just see a line, all right? Okay, so here's the Earth's plane. It's just a line here now. So instead of having, this beautiful, huge sheet of paper tilted, let me just show you a line. Now, here's a perpendicular line. This is a 90 degree, right? That's a 90 degree. That's a perpendicular line. Let me put the camera a little bit. Maybe you guys can see it all. That's a perpendicular line to the Earth's plane. So that's kind of like this. Again, this is a plane where the Earth is on. This is a 90 degree line, like that, all right? Like that. Now, the Earth's plane is tilted from that 23.5 degrees. I know, right? It sounds weird. So, in other words, this green line is the Earth's orbit. So this is 23.5 degree tilt. Because it could be this, right? It could have been this, but no, this is this. So you can say, if you want to write it down, the Earth's axis is tilted 23.5 degrees as compared to a perpendicular line on the Earth's plane of orbit. I know, that sounds like a heavy-duty thing. Basically, what it is, instead of going around the sun like this, like a good boy, it's tilted 23.5 degrees. That's all. No big deal.
Could you repeat that real quick?
Sorry?
Would you be able to repeat that real quick?
Sure. Earth's axis is tilted 23.5 degrees as compared to a perpendicular line to the Earth's orbital plane.
All right, thank you.
You're welcome. All right, so if it was a good boy, it'd go around the sun like this. That'd be 0 degrees. But it's tilted 23.5 degrees from that. That's all. So instead of going around like this, it goes around like this, tilted. All right, like that. Okay, that's the tilt that causes the Earth to have seasons. If the Earth didn't tilt, there'd be no seasons. It'd be just one season. We can call it sheesh, season of sheesh, instead of fall, winter, spring, and all that. We go one season, sheesh season, all right? So let's draw the equator of the Earth here. There's the equator of the Earth. Here's the equator of the Earth. Equator of the Earth. Equator of the Earth, all right? Now, I don't know why I drew the line here. Not a good place to put a line. Now, I'm going to put the axis on now. So this axis, I'm going to put it in green so you can see it. It's like this. It's like that. There's a North Pole. There's a South Pole. Make this a little thicker. Okay, like this. Like this. Like this. Like this. Like that. And like this. Can you guys see that now?
Yes.
Okay. So now the Earth is going around the sun.
So we're imagining that this is one sheesh season, correct? This
That's
is without
correct. If the Earth was
greater
straight and
transit.
tilted, if you went around the sun like this, there'd be just one season. And in fact, Saturn, I believe, is almost 0 degrees, so there's only one season on Saturn.
Well, when you're tilted towards the sun, that's when you're in summer, and when it's tilted away from the sun, that's when you're in winter, correct?
Oh, is this Linda talking?
No, it's Eva.
Eva. Okay, Eva, I have a question to ask you.
Yes.
Since you opened up a can of worms. Just kidding. All right. So what season is it right now?
We're in winter.
Well, that'd be wrong.
So we're in spring.
Spring.
Are we in spring?
Summer and winter at the same time. We are so prejudiced towards people that live in the southern hemisphere.
Australia in
That's right.
Australia's in
summer.
summer.
It's summertime. So you always have 2 seasons simultaneously. That was a point. Thank you. Now, here it is. So half the Earth always gets the light, or half the Earth always gets the light. That's just the way it is. So let's take a look at half the Earth that is getting the light. Now, here's the North Pole of the Earth, right? Here's the North Pole of the Earth. Here's the South Pole of the Earth, right? There it is. Now, let's see how much of that is getting the light. So we said half the Earth is getting the light, so half the Earth is getting the light. So I'm going to put the light on half the Earth. Darkness on the other half. Like that, right? So now take a look. Is the North Pole in darkness or the North Pole in light?
North Pole is dark.
Dark, very good. So this is winter here. Is the South Pole getting light or is it
Yes.
dark?
Yes.
It's getting light. So that's the time we have summer here. Very good. Now let's go 6 months later here. We'll do the same thing. We'll have half the Earth get the light. And I'm going to mark the poles so you can see where the poles are. Like that. All right, so let me put some darkness here and put some sunlight here. It's exactly the opposite. Now the North Pole is in the light, the South Pole is in the darkness. Do you see that? So now we have summer in the Northern Hemisphere. So here is North Pole, South Pole. Here we have summer. Here we have winter. But now, the temperatures are not going to be as easy to figure out as you might think because of ocean currents, right? Like ocean currents in San Diego, they come from the North Pole. Did you guys know that? They come from North and South Poles. And so that's why the Pacific Ocean is always cold. If you've gone surfing here at La Jolla, you know how cold things are, or Del Mar, or I don't know, farther south. It's always cold water. But if you live on the Atlantic side, if you go on the other side of the United States, ocean currents come from the equator. It's always warm and nice. So there's a lot to consider when you talk about like temperatures. Well, if you go to Hawaii, it's always nice. It doesn't matter if you go in springtime, wintertime, whenever you go. It's because of the ocean, right? So that makes a huge difference too. Now, why is it that here we have summer and here we have winter and here we have summer and winter? It's not just because of the amount of light. It's also because of the angle of light. So what does that mean, angle of light? Well, sun's rays, when they come down like this at 12 noon, straight down, they heat you up. Like if you go at 12 noon outside, you're hot. Basically, your head is hot. Whereas you go in the morning or something, sun is lower in the sky. But at 12 noon, just think 12 noon. 12 noon, sun's rays are coming down like this. Whereas in the wintertime, like today, if you go out at 12 noon, sun's rays are kind of like this. This is called a shallow angle. This is called a steep angle. So a steep angle means a very big angle like this. This is a big angle. This is steep. So sunlight is coming down like that at 12 noon. It gets hot. But what if the sun's angle is like this? Right? If the sun's angle is like this. So sunlight is coming down maybe at 20 degrees or 30 degrees at 12 noon, right? So this is called shallow, a shallow angle. So it just means small. Shallow angle means small, steep means big. They even use steep and shallow, I believe, in financial situations. Okay, so here, if you watch this, you can see the sun's rays. Sun's rays. Remember here, I shouldn't have drawn the equator in red. There we go, there's the equator. Here's the equator. Now here, let's take a look at the sun's rays in the northern hemisphere. Look at that. Steep. How about in the south? Shallow, right? This is shallow. So that's why we have seasons. It's because of the sun's rays angles. It's not how close or how far away the sun is. Does that make sense to you guys?
Yes, sir.
Okay, now when you guys have a kid, please explain all this to your kids. Don't wait till they get to astronomy class to figure this out or find out. Okay? All right. I want to live through your kids for the next 10,000 years. Right. It's actually true, you know. Your kids will teach their kids will teach their kids. Pretty soon I'll be here forever. All right. Okay. Now I was going to show you guys some little videos of all this. So let's take a look at my little videos. Okay. Here we go. All right, you guys. Can you see this? Am I sharing the correct stuff with you?
Yes.
Yeah.
Excellent.
Yeah.
All right, now why isn't this thing not moving? Oh, the wrong thing. That's why it's not moving. It's in Photoshop. That's Photoshop. What happened to my stuff? I didn't close it, did I? No, it's open. Okay. All right, so let's see, you guys. I still don't see. Oh, there it is. Okay. All right, can you guys see that?
Yes, sir.
Professor.
Excellent. Okay, so this is exactly what we're talking about. There's summer, there's autumn, there's spring, and there's winter. Now, I want you to note something. In autumn and spring, the tilt of the Earth's axis is meaningless because both hemispheres are getting about the same amount of light. So you're not pointing at the sun or away from the sun. The tilt is irrelevant here. You're tilting sideways. So here and here in the spring and summer, it doesn't really matter, right? All right, that's just one version of this I'm going to show you. I've got more. I don't know which one would be like to your liking, but let's see which one you like the best. All right, so there's another one. See, here is pointing away, right here. Here is pointing towards the sun. But here and here, it doesn't matter which direction it's pointing to. It's not pointing towards or away from the sun. But there's more.
Can I ask a question?
Yes, please.
What happens that some places like Alaska, they are 6 months they have nighttime and 6 months they have daytime?
Well, we'll get there in a second, but basically the sun is in the southern sky half the time is in the northern sky. So when the sun is in the southern sky, then it'll be below your horizon. Remember Santa Claus?
Mm-hmm.
Celestial equator is around your horizon, right?
Yes.
Okay. Well, if the sun is below the celestial equator, it never rises. Do you see? It's okay if you don't see it yet. I'll explain to you again. No worries.
Thank you.
And you're welcome. So here and here, these are called equinoxes. Here and here are called solstices. Now, if you look at the angle, and I can't stop it, I got to figure out a way to stop this. Look at the celestial equator. See, celestial equator, like that. So the sun is below the celestial equator. Here, the sun is above the celestial equator. Here, the sun is on the celestial equator. I'll give you drawings of it, but I wanted to show you first. So this is the beginning of summer on June 21st, beginning of fall, beginning of winter, and beginning of spring. So twice a year. I'm sorry, yes.
I was just wondering if this has any effect on like the northern lights, like why that happens.
No, northern lights strictly caused by particles that come from the sun at high speed.
Oh, okay.
So the sun like has explosions, stuff gets spewed out into space and they interact with our atmosphere and they light up. Same as your fluorescent light bulbs. It's the same mechanism. It's called fluorescence. We'll talk about that later. All right, more. I just wanted to show you guys the tilt and how this thing is working. All right, so now look, here's the moon also going around us as we orbit the sun. So it's not just us, it's also the moon with us. And we're all tilted as we go around the sun. It's cute because this has the shadow of the moon too. Very cute. All right, now this one here also shows you one more thing. The Earth gets closer and gets farther because it's not a circular orbit, not exactly, close to a circle. And so the Earth gets closer and farther. Can you guys guess when we have summer in San Diego, is the Earth closer or farther from the sun?
Closer.
Closer.
Farther.
The first day. Yeah, so when we have summer in the southern hemisphere, then the Earth is closest to the sun. But for us, it's farthest. So that totally, discredits the idea that the sun is closer or farther during the summertime. In fact, it's the opposite. In fact, we're farther. We're not even closer. Now, I had one more drawing that I don't see here yet. I don't know why I don't have one.
I have a question.
Yes, please. Oh,
So it's not that like it's okay. So it's further, but it's the fact that the sun or the Earth is tilted towards the sun that makes it count.
And the angles of sun's rays are steep. At 12 noon, they come down like this, so they heat up the Earth.
Okay.
That's exactly it.
And during winter, they're shallow angles.
Right, exactly. So let's take a look at that shallow angle here. Let's take a look. This is the Earth normally that we have it, but now we're going to tilt it. There's the axis of the Earth, and there is the orbit of the Earth. Oh, see, it's tilted now. Now, what happens here? Here we're pointing away. So this is wintertime here. There's no light. 6 months later, the opposite. So now the northern hemisphere gets more light. This part of the comet gets more light. Again. Tilted. Look at the sun's rays here. Perpendicular here, but look at it over here. It's shallow. I think those blue lines are representing the shallow and thing. So you see, there's summertime. Okay, does that explain to you guys?
Yes, sir.
Excellent. Excellent. We'll do some more of this, but I don't want to give you too much at one time. I want to make sure you guys are just relaxed and enjoying yourself too. Okay, so I'm going to do something for you guys. I was going to show you real quick. I am looking at the southern sky now. We're looking south. So if you're looking for south celestial pole, you look south. You don't look north. So this is Australia. This is Sydney, Australia. 32 degrees south latitude. South celestial pole is 32.5 degrees above the southern horizon here, you guys. And you can't see north celestial pole. There's nothing in the north. Nothing. No pole here. North celestial pole is under the horizon. I could show you what's under the horizon, I suppose. I have a see-through horizon, so you guys can see it. There's a see-through horizon. There is no celestial pole. Yay. Actually, I think Linda asked me that exact question, right, Linda? We're talking about North Celestial Pole, South Celestial Pole. If you see more of the North Celestial Pole, you see less of South Celestial Pole. So let's see, let's go to San Diego. San Diego is 32 degrees north. Okay, so now North Celestial Pole now is 32.5 degrees above my, oh look, South Celestial Pole is here. I can see my own shoes. That's funny, huh? Where is north here? Southeast, where is north? I am lost here. At least I got my shoes. Okay. All right, let's go kill this shoes thing. Let's fill it up. We don't see shoes anymore. All right, so now we're looking north. San Diego, we're looking north. We see North Celestial Pole, 32.5 degrees above my horizon. All right, so there's North Celestial Pole. If I move to 10 degrees north in Mexico, now it's 10 degrees above the horizon. So it's the same as my latitude. If my latitude is 55, it's 55 degrees above my horizon. It goes way up. Now, the sky's rotating. As the sky rotates, you can see the constellations, which are 88 constellations altogether. They were thought up by the ancients. 48 of them are ancient. And then 40 of them are new constellations made in, 15th and 16th century. Now, some of these constellations never set from a given location. Like here we have 55 degrees north, England. These constellations, like Draco the Dragon, is not setting. It just keeps going around and around and around and never sets. Here, take a look at it. You see, it's never going to go below the horizon. But now if I go to a different location, let's say San Diego, 32 degrees north, some parts of this are going to go below the horizon now. So let's see. Same stars that didn't go below the horizon before, these guys are going to go below the horizon now. So the head of the dragon, below the horizon. You see? Now this guy here, Cepheus, it's not going below the horizon. It's called circumpolar. Circum is C-I-R, C-I-R, C-U-M. Either circumpolar constellations or circumpolar stars. So here we have less circumpolar constellations because the angle is only 32 degrees. If I go to 55 degrees, now there's a much bigger angle here below North Celestial Pole. So now there's a lot more circumpolar. If I go to southern Mexico, hardly any circumpolar constellations, almost no constellations, just some of the stars here. So we say these are circumpolar constellations. These are circumpolar stars and circumpolar constellations. Who doesn't have any? People that live at the equator. Look, they have none. No circumpolar stars. Which circumpolar stars are always above the horizon? Well, if you go, there's Santa. Here's Santa. Santa is North Celestial Pole on the zenith. So look at that, it's 90 degrees above the horizon. All of them are circumpolar now. Nothing is setting, right? Look at that. Nothing is setting. The sun is not up yet either. If the sun was up, it will also never set. It'd be a 24-hour sun, right? Let me change the seasons to August. So there's an August sky for Santa Claus. There's the sun, keeps going around. It's in the north. Sheesh. Have you guys ever seen the sun in the north? Never. If you have a window that faces north, you'll never see the sun. So Santa has all the stars in the northern sky as circumpolar. Now, let me put on the celestial equator. There's a celestial equator, same as Santa's latitude.
And Santa's latitude is 90 degrees?
90 degrees north. Please don't forget
Right.
to say
Thank
north
you.
and south. Yeah, that makes a little difference, right?
Yes.
All right. So now is the time to do one more thing before we say goodbye to each other. And that is this. I'm going to go load up something special for you. The Zodiac. Hopefully the program won't crash. All right, this is a program. Now this shows you the revolution of the Earth, not just rotation. This is revolution. So each position change is going to be one day. So tomorrow, bang. Somebody's got their cell phone on. So let's see who's got their cell phone on. Please turn off your cell phone. You can't have your cell phone on and your camera at the same time. You get feedback. Let's see, whose cell phone is it? I guess you turned it off, right? Whoever it was, they turned it off. Yay. Okay, so now this is, as we go around the sun, we have a different view of the sun. In other words, the background of the sun keeps changing, right? So let me just show you quickly. I'll just quickly show you. Look, if I'm over here, this is me. If I'm over here and I look at the sun appears to have a background over here. Maybe this is Scorpio, right? Whatever it is, right? There it is, like that. But then from here, 6 months later, when I look at the sun's background are these stars over here. Maybe, I don't know, it's like maybe the teapot, Sagittarius or something, right? I'm just giving you fake examples here, you guys, right? There you go, like that. So the background is always changing because the Earth's position around the sun is changing. It's kind of like, here is my finger is the sun, and I keep moving my head. So I see my finger against a background of different things, like that. Not very difficult to figure out. So the background of the sun keeps changing, and that's what I'm showing you right now.
But if we're seeing the sun, we wouldn't see the background.
Very good. Thank you very much. Was that Linda?
Yes.
Thank you, Linda. You get a point for that one. That's right. Very good.
Yes.
So the sun is in the sky, and the stars are also in the sky. So what's the deal? Well, the ancients figured this out. They figured out, they made a map of the sky so they could figure out where the sun is in the sky. In daytime, they could figure out where the sun is, what constellation the sun appears to be in. And this is called astrology. Specifically, this is called your sun sign. Like here is a Virgo. Your sign is a Virgo. So if the sun is there, then you're a Virgo the day that you're born. So your mommy is giving you birth in the hospital. I know that for a fact. Daddies don't give births. And so if you're a Virgo, and this is just for fun, you guys, don't take too seriously. Just from my experience, just fooling around with astrology. Virgos are either very, very clean or very, very dirty. My wife is a Virgo, so is my daughter. So they're both very, very clean. Actually, my daughter is sometimes, kind of messy, but they have a love for baskets. They get baskets. They have compartments for everything that they hold. If this is true, you can put if you're a Virgo and you know this is true, you can unmute yourself and say something. Now Libra. So a few days later, like 30 days later, the sun is going to be over here, Libra. Now, if you're born under this sign, you'd be a Libra, right? So this is normally going to be like in October, late September, October. If you're a Libra, okay, the cell phone is back on again. Somebody, please turn off your cell phone. I'm getting feedback, kids. All right. So if you're Libra, you're perfect. Like my mom was a Libra, perfect, right? Balanced. It's a balance. That's what Libra is. It's a balance, right? Like that, balance. So you're even keel. You never get too angry. You never get too upset. You never get too happy either. You're kind of like balanced. Oh, now you're a Scorpio. Oh my God, if you're a Scorpio. God help us from Scorpios. Just kidding, you guys. Scorpios are actually very they people fall in love with Scorpios. You know, they just say, "Oh my God, you're so good looking," or whatever. You know, Scorpios. But they're also very jealous and they're very dangerous. Like if you had a gun, please don't put it in your car if you're a Scorpio. Somebody cuts you off, you could possibly shoot them. You know, so they could be very emotional, very hot tempered, just for fun. You know. Now, what if you're Sagittarius? If you're Sagittarius, you got a million friends, but they're just acquaintances. It might be better just to have one or two close friends instead of a million acquaintances. So get that cell phone of yours and empty it out of all these acquaintances. Delete people's names. Does that ring a bell at anybody yet? If you're Scorpio, see, I can't see your faces, but I know some
Super
of
accurate.
so far accurate. Okay. What if you're
Mine's
a Capricorn?
accurate too.
If you're a Capricorn, you've been saving your money ever since you were a little kid. Your pennies are paying off now. You have a bank account ever since you were 12 years old, just because you're a Capricorn. If you want to borrow money, you borrow from a Capricorn. Now remember all these guys. All this sheesh, remember it, please. Aquarius. That's me, right? So if you're an Aquarius, you better watch where you're going because you're looking up all the time. You're just, science fiction. Maybe it's better to look at some science facts for a few minutes, you know? So yeah, you might fall into a hole in the ground if you keep looking up in the sky. But you're cool. You're cool. If you're Aquarius, you're cool. If you're a Pisces, you are this, I don't know, the sweetest guy or girl that ever lived, probably. You know, Pisces are just so sweet for some reason. Yeah.
They were crazy.
Right?
That's what I thought.
But
Like
they're super nice.
Water
They're
symbol.
super nice. Nobody's crazy, you know, but they're super nice. And then if you're Aries, you don't like details too much. Like you might even get National Geographic because you're into science. But you just look at the pictures. You don't look at the articles. And if you're Taurus, you have a hard head, meaning that you make the same mistakes over and over. Sheesh. Like you get the same boyfriend or girlfriend, same type, and then you make the same mistake over and over and over. That's called bullheadedness. But that's just Taurus. But that's okay. They're also very, very nice. If you're Gemini, your name may be Dr. Jekyll. Could also be Dr. Hyde. So that's what Gemini tell me, that they all of a sudden they change personality overnight, sometimes in 1 hour, sometimes in 10 minutes. My best friend is a Gemini. 1 minute he's angry at me, the next minute he's the sweetest guy ever. It happens. Anybody Gemini in the class? Verify that I'm not just shishing you, please.
No, but my best friend is. My best friend is the same way. She's
Yeah.
very hot and cold.
Yeah. Cancer. All right, so Cancers, they are into exercising. Cancers are into exercising. They just love to exercise. So you'd be good at it. You'd be good at any sport that you choose. You're just in your body. You're physical. And if you're Leo, oh yeah, Leo. There's a huge difference between Leo men and Leo women. Leo men stay home and they look pretty, like the lions. Leo women, they go to work all the time. They work their sheesh off. And Leo men just look pretty. So yeah, my brother's a Leo. He used to beat the sheesh out of me. And he used to think he's the most handsome guy that ever lived. And then I had a girlfriend that was a Leo, and she was the most hardest working person I've ever seen. And back to Virgo. So remember, this was all just for fun and games, man. This is just my birthday present to you guys. I hope you guys enjoy yourself. Sorry if I said anything not totally complimentary to you. So, Linda, what are you?
I am a Libra.
Libra, uh-huh.
Yeah.
Like my mom. Yeah.
Yeah, I do. Fairness is a big deal for Libras as well.
Right? Yeah.
You want
You're
things to be
balanced.
fair.
That's right. That's why you're
Pulled
balanced.
out. Yeah.
Rectamundo. My mom was so fair, it was ridiculous.
Ah.
Yeah. No, take it to the edge, basically. Lourdes, what are you?
I'm also an Aquarius, so I agree. We're very cool people.
Yeah, of course. Yvonne, what are you?
I'm a Virgo.
Virgo. They have baskets?
Yes, for everything.
Lots of baskets. Noah, what are you?
Oh, same as you, Aquarius.
Aquarius. Okay, very cool. Cindy, what are you?
I'm an Aries.
Aries. Do you guys?
So I think you're correct on the lack of details, Majig, because I'm very like I get things and we're very scattered.
Yeah, well, I learned all my astrology from my mom's Cosmopolitan magazine. It should be accurate. I don't know, man. You guys, I'm gonna stop the recording. All this stuff